Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at stateless address auto configuration. We'll be discussing a SLAAC overview, enabling SLAAC, the SLAAC only method, ICMP version 6 router solicitation messages, host process to generate interface ID, and then finally we're going to look at DAD, duplicate address detection. This episode is part of my series on switching, routing, and wireless essentials. I'm Kevin here at KevTechify. Let's get this adventure started. When we talk about stateless address auto configuration, not every network has a DHCP version 6 server on it. Not every network will. And they've specifically designed IP version 6 and DHCP version 6 to work without having to have a DHCP version 6 server. That's where the stateless address auto configuration comes in. Every device on your network, they need that IP version 6 address, but they may not have access to a DHCP version 6 server. This is where SLAAC comes into play. It enables that host to create their own unique IP version 6 address. SLAAC is a stateless service. A stateless service, once again, is a service where nobody's keeping records of that. There's no record anywhere of what IP addresses are being used, what IP addresses are associated with what MAC addresses. There's just no record of that. SLAAC is an independent process. There is no DHCP server available for this, so there is no record of that. Now, this is done by our router advertisement messages. These are sent out, ICMP version 6 router advertisement messages. They're sent out every 200 seconds or so. Gives you an update on your information. And it allows the host to figure out, okay, how do I set up my addresses? How do I get my IP version 6 address? How do I create or get my global unicast address? When a host wants to figure out what their global unicast address is, they send out a router solicitation message. That's a broadcast that goes out onto the network, and any device that's listening for this specific broadcast will respond with that with a router advertisement. So router advertisements are sent out every 200 seconds or when they get a router solicitation in there. You can deploy SLAAC here two ways. You can you can deploy stateless address auto configuration by itself. And you generate your global unicast address and there's no additional information. But if you also want to supply some additional information, what you can do is use SLAAC, but then have a DHCP server on your network somewhere that will supply additional information. To enable stateless address auto configuration, to enable SLAAC, a couple things you have to do. You have to configure your interface with an IP version 6 address. Here we can see we do a show IP version 6 on interface gig 001. A couple things we can pull out. That it is set with a link local address, FE80::1. The IP version 6 protocol is set up in a way that the default gateway, the exit on and off of your network. So we have a network here with a PC, a switch, and a router. The exit off of your network, the default gateway, how you get on and off of your network. It's on your network, but it's connected to a device that allows you to go to other networks. The link local address that has the host portion, that last portion here, the right portion, set as 1. So FE80::1, that is the default gateway. That is that exit on and off. This is part of the protocol. And so FE80::1 will always be your default gateway. And up here, we're on router 1. We're looking at the gig 001 interface, which this is, and it is assigned this FE80::1 address. That makes our default gateway our link local address. Also down here, that same interface has been assigned our global unicast address. Right here's our global unicast address. Global unicast addresses typically start with 2001:DB8. That's one way you could tell what it is. And then we also have what our subnet is. Our subnet portion is the beginning left portion in an IPv6 address, and then it also says what our prefix is. How many bits of this entire IP version 6 address is our network portion? And it was a /64, so it's half. The first half is our subnet portion. Most IP addresses, IP version 6 addresses in today's world, typically use a /64 prefix. Now, a couple things to look at down here. This router has joined a special multicast group, FF02::1. This FF02::1 is a multicast group. FF002 signifies this is a multicast, and then ::1 is a special group. What this is, it's part of the all nodes group. And so all nodes in our local network is part of this group. And so that's what we have. Now, one of the steps you have to do in order to enable routing on our router for IP version 6 is you have to enable it. How do we enable it? That's what this command is here. The command to enable IP version 6 routing is IP version 6, and then we have unicast-routing. If you don't turn that in, your router will not route IP version 6 traffic. You have to do IP version 6 space unicast-routing. One of the final steps you have to do to enable SLAAC, the stateless address auto-configuration, is make sure your router, specifically that interface, is part of a special multi-class group. Here we have what groups we've joined. Up here we issued the show IP version 6 interface G001 command and show me the section on that starts with join. So we have join groups here. We have a couple multicast groups. The first one here, that was all nodes. So every node in our local network is part of this group, and that's sort of like a broadcast to our local network. The other group that you have to join here is the all routers group. The all routers group says, okay, if you're part of this group, you're a router. And then when we send out router advertisements, router solicitations, it can be sent to that group, FF02::2. When it's sent to that, all the routers who's part of that group get that router advertisement, that router solicitation, and then they can respond accordingly. If you like this episode on stateless address auto-configuration, also known as SLAAC, and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get this episode in video and podcast form. When we use stateless address auto-configuration only, so there is no DHCP server, we're not pulling other information, we're not doing a manage address configuration. When we're only doing stateless address auto-configuration, this is how our flags are set. A is set to 1, and then O and M are just set to 0s. And once again, that means the device, the host, is responsible for generating its own global unicast address. When those flags are set, we will generate our own address. And here's a screenshot of Windows command prompt, and we typed in ipconfig. This is listing out an IP version 6 address. This host generated that IP address. Now, nobody is keeping track of what address it is. Nobody has a record of what address, what device it's on, what MAC address it's on. It's stateless here. And also, we set our default gateway to FE80::1. This is set because of the IP version 6 protocol. Your link local address, the first one, so with the ::1, is always going to be your default gateway, your exit on and off of your network. That would be right here on this interface. Through the process of a PC booting up and connecting to my network, when the PC boots up, it sends out a router solicitation message. This RS message gets sent out. That RS message, that is directed to a special address. That's FF02::2. Once again, that was the multicast address for the all routers group. We send out this router solicitation message to all of the routers. The routers hear that. What they do then is respond back to the all nodes group. And so this message goes to the FF02::1. That goes back there, and that sends out the information on how to configure your IP version 6 information, specifically how to configure your SLAAC to get your global unicast address and how to generate it. So the first step, once again, is we send out a router solicitation message to the all router group multicast. Router gets it in, sends back a router advertisement to the all nodes multicast group. The PC gets that in, and then it's able to configure its IP version 6 information. How a host generates this ID, the 64-bit ID, which we refer to as our IP version 6 global unicast address, is it gets the router advertisement here. It sent out that router solicitation. The all routers group herds it, sends back a router advertisement to the all nodes group. It gets that router advertisement in, and then it generates the 64-bit interface ID. And there's two methods to generate that. One is a randomly generated 64-bit. Once again, our IP version 6 address is 128 bits long. Most networks, almost all networks in today's world, use half of that as the network portion, half of that as the unique identifier portion at the end. The network portion is set by the administrator or generated on the router. And so it gets that information from the router advertisement, but also it gets information on how to generate that remainder 64 bits. Now, to generate that remainder 64 bits, that interface identifier, there's two methods. One is randomly generated. We can go in and we can randomly generate 64 bits and have that be that identifier. The other method is what we call the EUI64. What this does is it uses the MAC address. The MAC address is 48 bits long. We have to generate 64 bits. What we do here is right in the middle of those 48 bits of your MAC address, right in the middle. So you got 24 bits on one side, 24 bits on the other side. We stick in some more bits. We stick in a hexadecimal FFFE. And when you look at a IP version 6 address and you look at the last part of it, if it has FFFE in the middle of that last part, you can tell that we use the EIU64 part. There is a issue that some people have using the EUI64. The EUI64, because it uses your MAC address, we could then track your device using that. If you got the IP version 6 address of a computer, you can see what the MAC address is. And because in theory that MAC address shouldn't change, we can now start tracking where that device is. And so it's a privacy concern. In a lot of operating systems, Windows, Linux, Mac OS, they allow the user to choose either the randomly generated or the EUI64. Windows by default, Windows 10 host, they use the randomly generated 64-bit to generate that last ID portion. There's a process out there called duplicate address detection, or we call it DAD for short. And what this allows us to do is to make sure we don't have duplicate addresses when we generate our global unicast address. What we do is when we generate our global unicast address, we generate that last 64-bit identifier. We send out a neighbor solicitation. This neighbor solicitation has the last 24 bits of the IPv6 address. It sends it out. And if there's somebody that has the last 24 bits that match my 24 bits, I'm going to get a message back. And that's going to say my address is not unique. If I don't get back a neighbor advertisement, then we're going to say, yes, it's a good address to use. There's something fun that they talk about here. And they say, if I don't get back my neighbor advertisement message, it's virtually guaranteed to be a unique address. Now, I love how it says virtually guaranteed. Now, because the 64-bit interface provides 18 quintillion possibilities, because there's 18 quintillion possibilities, we're going to assume that if we just compare the last 24 bits, that it's going to be unique. And it doesn't compare the full 64 bits of that identifier, that ID. It just does the 24. And so if it doesn't match 24, we're going to say it's virtually guaranteed. And if we do get a message back and it's not unique, we just generate another one and we send it out. And it will probably work. Most of the time, if it's not unique, generate another one and it'll work. It was my pleasure to provide you with this wonderful episode on StateLess Address AutoConfiguration, also known as SLAAC. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.